everybody. Today we are going to talk about similarity transformations, and this is from lesson 4-5. Yesterday, or in the last lesson, you learned about similar figures and what those are, and we just want to remind ourselves of that definition really quick. Similar figures are any figures that have the same shape but aren't necessarily the same size. And today we're going to talk about similarity transformations, which is how I can do a transformation like what we've done in the past, where we had translations, rotations, reflections, those types of things. Only now, instead of being a congruence transformation where the two figures were the same size and same shape, they were congruent after we transformed them, we're going to do these transformations and we're going to end up with a similar shape. So it'll be the same shape, but a different size. So this lesson goes with the learning goal. I can graph dilations and determine the scale factor of a dilation. And so our two definitions that we're going to start off with are what is a dilation and what is a scale factor. So a dilation is a transformation in which a figure and its image are similar. So instead of having the image and the pre-image be congruent, now they're going to end up being similar. And the scale factor is just the ratio between any two lengths of the figures in the image and the pre-image. And we say corresponding lengths because you want to be comparing the same sides. So if I have a triangle, a right triangle, I would compare the hypotenuse of the image to the hypotenuse of the pre-image. But you have to make sure that you're always comparing the same side when you do this ratio, and it's a ratio of the image to the pre-image. So we're going to highlight that and make sure that we remember when we write our ratio, the first number is going to be the image length and the second number is going to be the pre-image length. So that's the ratio that we want to create. The answer to the free response question is brr, it's cold outside. So we're going to start with an example here. We want to find the image of the triangle DEF with vertices that are listed there after we have a dilation with center D and a scale factor of 2. So let's first start by graphing that triangle and seeing what that would look like. Because this problem tells us that D is the center of this dilation, that means that the image point for D is going to be in the same spot as the pre-image point. So D is going to be equal to D prime. That point right there is not going to change. And since we have a scale factor of 2 for our dilation, that means that each of the side lengths is going to be twice as long in our image as they are in our pre-image. And so if I count along here, I can see this side length right here is vertical. And so I can just count squares right here to find the length of it. And I can see there's 1 square, 2 squares, 3 squares. So this side, DF, has a length of 3. So in my image, I need to have a length of 6 because I'm doubling the length. Since D can't move, D prime is the same spot as D, I have to move down 3 more points here. 1, 2, 3. And this becomes F prime. So now if I draw this line in here, you can see that that is twice as long as the original leg length right here. Now, my other side length right here, I can also just count squares because it is a horizontal line. And so I need that one to become twice as long as well. And you can see it starts out at 1, 2, 3, and so it needs to be 6 units long as well. So I need to count over from my new image point, F prime, 6 units. 1, 2, 3, 4, 5, 6. And so E prime will go right here. And again, I can graph that or draw that line in, and you can see it's twice as long. And then the diagonal line, I would have needed to use the Pythagorean theorem to figure out the length of that side, but since I now know where D prime, E prime, and F prime are, I don't actually have to do that. I can just draw that point in. Most of the dilations we're going to do are going to have a center of 0, 0, and they're a little bit easier to do. So if the book doesn't say doesn't specify what the center is, you can assume that it's 0, 0. And so when we do a dilation with a center of 0, 0, that's simpler to do, and I'll show you what that looks like right now. So here is a quadrilateral, KLMN, and we want to do a dilation that has a scale factor of 3 to 2, 3 halves. So each side length in my image, my new image, are going to be 1.5 times bigger than the side lengths in the pre-image. And they didn't tell me what the center is, so I can assume it's 0, 0. So when I do a dilation like this, all I have to do is figure out what the original points are, and then multiply both the x-coordinate and the y-coordinate for each point by my scale factor, which would be 3 halves in this case. So I need to figure out all my different points. So now I'm going to take every single one of those numbers, both the x-coordinate and the y-coordinate, multiply it by 3 halves, and that will tell me what my new image points are. So L prime, I would take -2 times 3 halves, and so I could do that off to the side here. So 3 halves times a -2 over 1. I can see that my answer is still going to be negative, but other than that, these 2's cancel because there's one on the top and one on the bottom. So I'd have -3 over 1, which is just -3. And then a +2 times 3 halves is going to give me the same thing but positive. So that would be 3 m prime. I'm going to multiply 1 times 3 halves, which will give me 3 halves. And I'm going to multiply 2 times 3 halves, which I know from my previous multiplication will give me 3. So then my second step down here, step 2 when I do this, is just a graph. So I'm going to come over here and do that. So now I should have a figure that is similar, so it's the same shape, but a different size, 1.5 times bigger. The side lengths would be 1.5 times bigger than the shape that I started with. And allowing for the fact that I don't draw perfectly straight lines, you can kind of see that that's the case. All the corresponding sides are parallel. All the angles should stay the same measurement, just like we have with normal similar figures. And so you can see when we have a center of 0, 0, doing a dilation is just a matter of multiplying each coordinate by the scale factor. Okay, so we have 2 types of dilations. We might have an enlargement or we might have a reduction, and those are pretty much what they sound like. An enlargement is a dilation that has a scale factor greater than 1, so the image ends up bigger than the pre-image. And a reduction is a dilation that has a scale factor less than 1, so the image ends up smaller than the pre-image. And here's a problem where we need to figure out the scale factor, and in order to figure out the scale factor we just have to think back to our definition of what a dilation is. So I'm going to switch back to that really quick. You can check in your notes. Remember that a scale factor is the ratio of the length in the image to the corresponding length in the pre-image. So I need to do a ratio of image to pre-image of 2 lengths that are in the same place in the figure, they're corresponding, and then I need to simplify that as much as I can. So here it says the blue figure shows the outline of a yard and the black figure is a doghouse. The blue figure is a dilation of the black figure. So the blue figure is the image. So I'm just going to label that now so I don't forget. This is the image, which means that the black figure is the pre-image. So the blue figure is a dilation of the black figure. Find the scale factor and then say whether it's an enlargement or reduction. Even without finding the scale factor, I can probably see that it's an enlargement because the blue figure is bigger than the black figure. Once I know which one's the image and which one's the pre-image, if it's bigger, it's an enlargement. So that tells me my scale factor needs to be larger than 1. Because this is an enlargement. So I'm going to write, I see that we have this 2 side lengths, that shorter side length and that longer side length are the 2 that are labeled there. I want to write a ratio of my image length, 6, to my pre-image length, 3, and then I want to simplify that, and that'll be my scale factor. So 6 and 3 are both divisible by 3, so I can simplify this to a scale factor of 2 to 1, which reduces to just plain 2. So my scale factor is 2, which is good. It's larger than 1, which is what I expected because this is an enlargement. Here are your free response and multiple choice questions. Pause the video now and answer them both. Thank you.